Hello everybody. I hope you didn't have too much trouble with lesson 4 and pulling everything together into one place with sine and cosine. If you did, I hope you emailed me all your questions. If not, go back over it and email me your questions today because I will absolutely do my best to answer you. Now we're going to continue with sine and cosine. So the bottom of this one says lesson 5, but we're still going with sine and cosine. So if you notice, I still have up my sine, cosine, tangent of my quadrantal angles. I have up my sine, cosine, tangent of my special right triangles, 30, 60, and then the 45. I have up my all students take calculus to remember who's positive in each quadrant. The Pythagorean identity, cosine squared plus sine squared is 1. And I have my functions, sine, cosine, tangent. And again, my reciprocal functions, my flips. So I'll write reciprocal. Sine flips to cosecant, which is hypotenuse over opposite. Cosine flips to secant, which is hypotenuse over adjacent. And tangent flips to cotangent, and that would be adjacent over opposite. So with all this important stuff being left on the board, I want to work through lesson 5. And if you notice on exercise 1, again, they're talking about being on the unit circle. And they're saying the sine of theta would equal. So exercise 1. Sine of theta on the unit circle is the y coordinate. Cosine theta is the x coordinate, and this is on the unit circle. So important. We'll actually even leave exercise 1 up. But let's take a look at exercise 2. It says, given the function that f of x is equal to 6 sine of x. And then they say, find first, please, the function at 60 degrees. Well, this means 6 times the sine of 60 degrees. Well, what is the sine of 60? Well, here's the sine, here's 60. Sine of 60 is rad 3 over 2. So this would be 6 times rad 3 over 2. I can reduce diagonally, and this gives me 3 rad 3. So now it's just kind of pulling together a lot of what we've done. Exercise 3 tries to make it a little bit more of a challenge, but I don't think you guys are going to fall for that. I don't think you're going to get nervous or scared. Exercise 3 says 4 cosine, or actually g of alpha, is 4 cosine of alpha minus 2 sine of alpha. And then they say, let's use alpha as 330 degrees. So now they want g of 330 degrees. Well, 330 degrees is a quadrant 4 angle. So before I go any further with this, I am going to draw out quadrant 4. Now, quadrant 4 has a positive x and a negative y. So here I am in quadrant 4. Quadrant 4 is cosine's quadrant. Cosine is positive, and sine then is going to be negative. So that's pretty important here. So when I have 4 cosine of 330, 330 going all the way around into quadrant 4, cosine is positive. And now I have 2 sine of 330. However, sine in quadrant 4 is negative, and that matters to me. Remember, the positives and the negatives are my locations. So this guy is negative in quadrant 4. The reference angle, if I went 330, I have a 30-degree reference angle. So this is now equal to 4 times the cosine of the reference angle of 30, which is positive in quadrant 4, minus 2 times the sine, reference angle sine of 30 degrees, but this is negative in quadrant 4. So the cosine of 30, if I come up here to my chart, the cosine of 30 is rad 3 over 2, and it's positive, so this is now 4 times rad 3 over 2. And here I have minus 2 times a negative, double negative. This is now plus 2 times the sine of 30, which is 1/2. Well, let's reduce. 2 goes into 4 twice, so this now gives me 2 rad 3, and 2 goes into 2 once, they cancel, plus 1. Here's my exact answer, 2 rad 3 plus 1. This is exact because it is in radical form, that is irrational. This is rational, they must stay separate because of the categories. So I thought that was kind of fun. It really ties everything together that we've done basically the whole year. Number 4, which of the following is not equal to 1? Well, if you know your chart for the quadrantal angle, you can answer that. So I'll give you a second while I erase the board to look at your chart, answer that question, and then I will go over it. So, which one is not? Would be choice 4. The sine of 270 is -1. They wanted +1. So number 4 was choice 4, 270. Now let's take a look at number 5. For angle alpha, whose terminal ray lies in the 3rd quadrant, it is known that the cosine of alpha is -0.96. All right, so I need quadrant 3. I don't need, so negative for sine and negative for cosine in quadrant 3, because this is tangent's quadrant. And if I draw the ray to the point, I have, again, the cosine is -0.96. That's my cosine because it's the x-coordinate. And they told me, and they want to know what sine. We want to know sine, so we want to know the y. Now the y is also negative. But if we're going to look at this, we know the negatives are telling us our location. So when I do this problem and I say, okay, cosine squared, 0.96 squared, because the negative, again, location, I don't need it here, plus y squared, or sine squared, either one, is equal to 1. And I'm going to need the calculator because last time I checked, I cannot do this in my head. So when I have 0.96 squared, I get 0.9216. Plus my y coordinate, my sine squared, equals 1. So now I'm going to subtract my 0.9216. So 1 minus that answer gives me 0.0784. And I'm going to take the square root. And I get that y is 0.28, which means in quadrant 3, this would be -0.28. So the sine of this angle in quadrant 3 would be negative 0.28. Since they gave me decimals, I'm going to keep the decimals, and that would now bring me choice 2. Hopefully that felt comfortable to you. Let's take a look at the next page. Now they're asking you to pull together your reference angles and your sine and your cosine, and using the calculator. So let's make sure the calculator is on degree mode. So double check your calculator, please. Make sure you're in degree mode. So number 4 says that theta is 110. And the reference angle, so it says in each of the following, an angle and its reference angle are given. So 110, this is quadrant 2. And so the reference angle, so theta sub r for the reference angle would be 70. Makes sense. 110 and 70 brings us to 180 degrees, which is the boundary, the quadrantal on quadrant 2. And they're saying determine the sine and cosine of both the angle and the reference angle. They want you to be using your calculator. So, being that I need to be in degree mode, again, check your mode, make sure you're highlighted in degrees, make sure that box is on degrees, and we want the sine of 110, so we type that in, just sine of 110 now, degrees, and you get roughly 0.94, they said round. And if I typed in the cosine of 110, this should be negative because I'm in quadrant 2, which is sines. So cosine of 110 gives me negative 0.34, which would make sense. Let's do the reference angle. If I did the sine of 70 and the cosine of 70, I'm going to get sine of 70, the same, 0.94. Now cosine of just plain old 70 would be quadrant 1. If I typed in the cosine of 70, I get 0.34, which is positive. And then if I say to myself, okay, this reference angle is in quadrant 2, then that's when I say, okay, I'm now negative cosine of 70, which would make me then negative 0.34. So number 6 is typing in the angle and the reference angle. I'm going to leave that to you to do. You don't need me to do that with you. And if we now want the exact form of these angles on number 7, these are all about the reference angle and where I land. So if I take number 7, part A and part B, it's all about 150 degrees. So number 7, A and B, is all about 150 degrees. 150 degrees, quadrant 2. So here's my quadrant 2. So if I draw my 150, that gives me my reference angle of 30 degrees. And if my reference angle is 30, and in quadrant 2, A was the cosine of 150. This is now negative cosine of 30 because, again, reference angle of 30, quadrant 2 for cosine is negative, and I can either draw out my numbers opposite of 30, 1 to 2 with the hypotenuse, rad 3, or I go to my chart. And my chart says the cosine of 30 is rad 3 over 2. Cosine of 30 here, rad 3 over 2, negative. And the sine of 150 is equal to the positive sine of 30, because again, I'm in quadrant 2, sine's quadrant, this would be positive 1/2. So as long as you can draw out the angle and its reference angle, and then you can go to your charts, you're going to be able to answer 7. And I'm going to let you finish 7, and I'll have the answers posted. And then let's take a look at 8. 8 is a little bit different because they're now starting us out in radians. Well, if they're starting us out in radians, I am going to have to think about the radian measure. I can convert to degrees, I can leave it in radians. So if I have number 8a, the sine of pi over 2, remember, radians to degrees, take my pi over 2 radians and multiply this by 180 over pi. This gives me a 90-degree angle. So, what is the exact amount of the sine of pi 2 radians? That would be the same as the sine of 90. That's a quadrantal. That would equal 1. Number 8, part B. B is saying the sine of pi over 3. So again, do the conversion. Pi over 3 times 180 over pi gives me 60-degree angle. So what's the sine of a 60-degree angle? Well, here, sine 60 degrees. This is positive rad 3 over 2. So if you can do the conversion, this is pulling in less than 2, you're in business. Now, cosine of 3 pi over 2 for C. Cosine of 3 pi over 2, let's see what this is. 3 pi over 2 times 180 over pi. This actually gives me 270 degrees. This is a quadrantal. Cosine 270, 0. And finally, we have the cosine of 3 pi over 4. I have to get rid of this now. Cosine of 3 pi over 4. Now, 3 pi over 4, just if we want to talk about this for 1 second, as a fraction, 3/4 says 0.75. So that's not 1 whole. So I know if I was 1 pi, I would be 180 degrees. So 3 pi over 4, 0.75 pi tells me I'm in quadrant 2. So if I want to check that, 3 pi over 4 times 180 over pi, again, pi's cancel, 4 goes into 180 45 times. This is 135 degrees. Definitely quadrant 2, which makes cosine negative. Quadrant 2, cosine's negative, and 45 degrees negative rad 2 over 2. So I hope everything is starting to really come together for you guys. I hope you're following and this is making sense. I do want to go to the fluency page and do number 4, just because I think this is one of the ones that might throw you a little for a loop. I want to work through this one with you, and then I will say, you know, have at this packet, and email me with any questions. So fluency page now, this is on page 3, and this is number 4 on page 3. So number 4, page 3. You have cosine of beta is negative 8/17. So the cosine of beta is negative 8 over 17. Now again, the negative is telling me the quadrant, and they're telling me in the problem this is quadrant 3. I know cosine is negative in quadrant 3 because this tangent's quadrant. That means sine is also negative in quadrant 3. But if I take a moment and I draw myself quadrant 3, and here's my angle beta. Whoops, I drew it, sorry about that. Here's my angle beta in quadrant 3.
I have to run the catalog and drop something off to my mother and then stop at the switch station.
So cosine is adjacent over hypotenuse. Adjacent, here's my 8, and here's my hypotenuse is 17. So again, the negative on x means I went 8 in the negative direction. What's my altitude? Pythagorean theorem. A squared plus 8 squared is equal to 17 squared. So a squared plus 64 is equal to 17 squared, which I should know this, but I don't, so I'm just going to type it in fast. Don't want to make a mistake. 289. I'm going to subtract 64 from both sides. So that gives me 225. Take the square root, and a is 15. So that means now I am going 15 downwards. That's negative y. So again, that's now going to make my sign negative as well. And they're asking me what would be the sign. This would be the sign, which would be 15 going down to the hypotenuse 17. Now, they don't ask us for this, but we could do it anyway. If you know one and you can do the Pythagorean theorem, you know all 6 functions. Here's sine, here's cosine. If I wanted the tangent would be opposite over adjacent would be 15 over 8, and it would be positive because the double negative is positive, and this is tangent's quadrant. If I wanted the reciprocals, the reciprocal of cosine is the secant. So the secant would be negative 17/8. Just flip it. The cosecant would be the reciprocal of sine. Take this guy, flip it, negative 17/15. And then finally, the cotangent would be this guy, 8/15, and he's positive. So when they give you a ratio, go back to your SOHCAHTOA, label a triangle, Pythagorean theorem, and then write your ratios. Positives and negatives come from the location. I hope this helps, and please, again, email me with any questions, and I will talk to you then. Stay safe. Bye-bye.